Hi everyone and welcome to this channel. My name is Mohib and I am a SQL Server professional and a Microsoft Azure certified data engineer. And today I'm going to show you how to work with JSON data in SQL Server. And we will see how we can use the built-in SQL Server JSON functions in order to extract information out of our JSON. So first things first, what is JSON? Well, it stands for JavaScript Object Notation, and it is one of the most widely used data exchange format between different applications. One of the applications of JSON is when a web browser communicates with the web server calling the AJAX method, which then sends HTTP requests to the web server. The web server acknowledges the request, fetches the requested data, wraps it in a JSON object, and then send the response back to the web browser where it is converted in HTML and displayed on the web page. So the transfer of data between the web browser and the server is most commonly done in the form of JSON these days. For data engineers though, the most common use case is when data streams comes in from external system, for example from IoT devices. And then data engineers typically create data pipelines to channel the streaming data from source to destination or multiple destinations. In this diagram, the data pipelines channels the source data to two destinations. An external application is being updated in real time using the real-time data streams from the source. On the other hand, the original raw JSON objects from the source are also being stored as it is in a database like SQL Server for our future analytical requirements. This is one example on how we can get JSON data in SQL Server, and to perform our analysis on it, we have to extract data out of it using SQL Server built-in JSON functions. Here is one example JSON that corresponds to one packet from the stream of data we are receiving from the source. What this JSON is doing is that it's telling us about different features of a device, and it is also giving us the temperature readings from a sensor attached to it. And at the end, we also have a comments field telling us if the device is behaving normally. Now let's jump to our SQL Server and see how we can extract this information out of the JSON. Alright, so now I'm in my SQL Server Management Studio, and here's our sample JSON, and what I have done is that I have assigned this JSON to a variable called JSON. And now let's look at what built-in functions we can use in order to work with that JSON. Right, so first we have the ISJSON function, and really what it does is that it validates the JSON. So it will return either 0 or 1 depending upon whether or not the JSON is valid. So if I run this, it will give me, so it gives me 1, which means that my JSON is in valid format, right? So this is the only purpose of this ISJSON function, and it's always a good idea to validate something before actually using it, so that is why this function is here. The next function is JSON underscore value, and it returns a scalar value out of a JSON. It takes two parameters. The first one is the JSON, and the second one is the path to the value that we are looking for. So in this case, I am looking for the value of the comments field inside the JSON. The $sign here is actually the root of the JSON, and we have to specify it every time when we are specifying a path to a certain field. So if I run this JSON underscore value function and I'm looking for comments value, it should return me the value of the comments, right? We can also use JSON underscore value function to actually fetch the values of the nested fields. In this case, I'm looking for the value of type, which is inside the geometry object right here. So type is inside the geometry object, and if I run this JSON underscore value function, it should give me the value of type, right? Using JSON underscore value, we can also get the value out of an array. Coordinates is our array in our original JSON here, and in this case we are looking for the second value of the coordinates. Remember that array starts with a 0 index, so in this case we are looking for the first index, which is the second value here. So if I run this, it should give me 50.4742. okay. Now let's look at what the JSON underscore value function cannot do for us. Actually, it's meant to return the scalar values, like I said earlier, so it cannot return complete object. Like in this case, we have this properties object. Same goes for the arrays. It cannot return us the coordinates array as well. So if I run this, it returns me null, which means that this field cannot be returned, cannot be fetched by JSON underscore value function. So it returned us null, but what if we want to see error message? If we want to see an error message, then we have to type strict before our path. What strict does is it strictly applies a schema check or a validation check on the JSON, and before actually executing the JSON underscore value function, it applies this checks. In case of an error, it would return us an error message. So in this case, it said that the scalar value cannot be found in the specified JSON path, and sure enough, properties is not a scalar value. Alright, so JSON underscore value is only for the scalar value inside the JSON. And the next function is JSON underscore query, and it is the exact opposite of what the JSON underscore value does. So it cannot return the values from the JSON, rather it returns us complete objects. So now if I ask JSON underscore query to query the properties objects, it would give me a complete object. So here we can see that it's a complete object. And same goes for array. JSON underscore query can also get us the complete arrays out of a JSON. So I'm looking for coordinates array, and here it is. Alright, so what JSON underscore array cannot do is what JSON underscore value can do, and same is the other way around. Right, so the next function is JSON underscore modify. This function, as the name implies, it modifies the JSON and returns a new JSON, a new modified JSON. Alright, so it takes 3 arguments. The first is the JSON itself, the next argument is the path to the field that we want to modify, and the third argument is the actual value that we want modified. Right, so if I run this, here I am looking to modify the sensor value, so it should return a new JSON, new modified JSON with a sensor value of 2. Originally the sensor value was 1. Now it returned a JSON with a modified sensor value. And using JSON underscore modify, we can also append a new value to our array, right? So here we have this coordinates array, and we want to append a third value to this array. So if I run this query, it should return the modified JSON with 3 values inside the coordinates array, right? And we can also use JSON underscore modify to insert a new value in the JSON, or to delete an existing value from a JSON. How we can do this is really simple. So if we specify the path to have a field that already does not exist in our original JSON, so it will create a new field with the name that we have specified, right? So in this case, I'm looking to add a new status field in the JSON. It already doesn't exist, so it will add this field in the JSON. So here it is, it added status is equal to OK, right? And similarly, we can delete a value from the JSON, and if we want to delete the value, we simply have to pass null as the new value of the field, right? In this case, I want to delete comments field, so I'm going to pass null, and this will remove comments field altogether from this JSON, right? So in the new JSON, we don't have a comments field at all. And one more thing that we can do with JSON_modify is to rename the existing field. So in this case, I'm going to rename my comments field, and I'm going to assign it a new name, remarks, right? So the way I'm going to do this is by adding a new field with the existing comments value and then deleting the original comments value. And what I mean is that if you look at the inner JSON_modify clause here, then I'm passing it the original JSON and I'm adding a new field in it with the existing value of the comments field. Remember that the JSON value function returns a scalar value, and in this case it's returning me this scalar value, right? And I'm assigning it to the remarks field. After executing this statement, the new JSON will have both the remarks and comments fields. So I want to now get rid of my comments field, and what I'm doing is in my outer JSON_modify function, I'm passing it null so that it deletes the comments field altogether. So now if I run this whole thing here, I will get my new JSON and my comments is renamed, and the new name now is remarks, right? So this is how we can rename our JSON. Now let's see how we can use all these 4 functions with a table containing hundreds of JSON records in it, right? So we have this table called vehicle temperatures, and if I run this query, I get all of my JSON records in it. But before actually working with it, I want to modify this JSON so that it looks like our previous JSON that we have been working with. So let me just compare both of these JSONs for you. This is our original JSON, and this is the JSON format that we have in the table, right? Now if we compare both of these JSONs, then the highlighted portion is in exactly the same format on both sides. The difference is that on the right hand side we have this recordings field, which is actually an array that wraps the original JSON inside it. So we know that it's going to be redundant since we have only one JSON object inside that. So I need to remove this recordings from here. And another thing is that we don't have a comments field on the right hand side, and we need that, right? So now we have 2 changes to make, and let's see how we can do this. All right, so what I'm going to do is I'm going to use JSON_modify to add a new field called comments. Simple. So remember that if there is no existing field with the name comments, it's going to add a new field, right? And the way I'm going to remove the recordings array is by using JSON_query, which will return me an object inside of the recordings array. So now if I run this update statement, I got my 100 rows updated, and if I again select my vehicle temperature table, then I have both these changes made, and you can see that the recordings array is now gone and I have a new field called comments. Now if you try to use JSON_modify instead of JSON_query to get rid of the recordings array, because I said earlier that we use JSON_modify to delete something, so you will delete this recording array, but you will also end up deleting everything inside the recordings array, and we don't want that. So for this reason, we are using JSON underscore query here because it returns everything from a specified path, right? Now moving on, the next example we have is that we are using our scalar value functions in the where clause here, and I'm looking for all of the data from sensor 2, and I want to calculate the minimum and maximum temperature from sensor 2. So if I run this query, I get the minimum and maximum range of sensor 2 that it recorded. So it's really useful how we can use these scalar values, these scalar value functions in our where clause as well as in our select statement, and we can also apply the min and max functions on top of it, right? And in the next example, I'm going to calculate the average from both sensor 1 and sensor 2. So now I'm using my JSON value function in the group by clause, and I'm averaging my temperature from both of these sensors. So now if I run this query, I get the average temperature for sensor 1 and I get the average temperature for sensor 2. Alright, so we looked at 4 different JSON functions, and if you noticed, all of them are scalar functions, which means that they return a single value, be it a Boolean value, an array, or a complete JSON. It still is just one value. And we also looked at how we can use these scalar functions with tables containing hundreds of rows of JSON data and perform calculations and groupings on it. I think that's it for this video, and I will create a second part in which I will talk about other operations that we can perform on JSON. For example, how to parse JSON, apply custom schema on it, and also to convert it into a table. So stay tuned for the next part, and I hope you like this video. Take care of yourselves and have a great day. I will see you in the next one. Bye.